So let's read this problem first. A dumbbell-shaped object is composed by two equal masses, m, connected by a rod of negligible mass and length, r. If the inertia of 1 is the moment of inertia of this object with respect to an axis passing through the center of the rod and perpendicular to it, and the inertia of 2 is the moment of inertia with respect to an axis passing through one of the masses, it follows that I2 is greater than I1, I1 is greater than I2, or they're equal. So the first thing we can do in this problem is draw it out to get a better understanding of the two situations. So for I1, the shapes are like this, and they're of equal mass, and the radius is passing through the middle. And then for I2, it's perpendicular, and then there's a rod passing through one of the masses. And the radius is still here, but now there's a perpendicular rod in the middle. So this is I2, and this is I1. So the first thing we can do is do an equation to see what is the difference between the inertia of the first situation and the inertia of the second situation. So for I1, we know that the masses are equal. So the first thing we can do is multiply the equal masses times the radius over 2, because they have these two different quadrants that separate them, and then we would square this value. And then we would add this. Same thing again, since there's two masses on the dumbbell-shaped object, and they would just be added, and then this would give us 2 times the mass, the radius squared over 4, and then we can simplify these two numbers over here, and that leaves us with I1 being half of the mass times the radius squared. So this is the equation that we have for the first situation of inertia. And now for the second situation of inertia, we would simply have the mass times the radius squared, because we're not dealing with the two masses being split by the radius in this case. There's already a perpendicular rod going through them. So now we can simply just compare these two moments of inertia over here, and we know that half of the mass times the radius squared is going to be less than the mass times the radius squared. This is ultimately going to be a larger value every time. So we know that the moment of inertia in the first situation is going to be less than the moment of inertia in the second situation. So that leaves us with option A.